Hi guys, this is Rashid and welcome back. Today I would like to show you about this gimbal camera. So this is XACTI CX-GB400 optical zoom gimbal camera. XACTI is the child company from Sanyo, which is the well-known electronics manufacturer in Japan. If you are looking for the Japanese quality gimbal camera, here is the one you might check it out. So this is the CX-GB400 optical zoom gimbal camera. On the right hand side here, you will see there's an SD card slot. And at the back, there are 10 pins connector which need to be plugged on another base plate, which is going to provide a USB interface. You can choose either upper mount or lower mount, and then you can define that later in the software. And this is the base plate AXDM100. You will see there's a holes to connect this plate on the vehicle. In the front left here, you will see there's JST connector port, which is for the power cable. And on the right hand side, there is a USB-C type port for the communication. So you will need to plug this gimbal camera onto the base plate and then sliding into the end. And then lock it up on the both sides. So make sure that the camera is stay in place. You will need to insert the micro SD card in order to store the photos and videos. And you will need to make this JST connector, and depends on how you're going to provide 12 volt. So in my case, I'm going to use XT30. Then connect this JST power connector to the gimbal. And then connect the USB-C type. The camera is using UVC protocol to set the camera parameters and to control the gimbal. After researching, I found that there is no ROS package to control this gimbal camera device, so I decided to make my own. Here is my ROS2 package to control XACTI CX-GB400 gimbal camera. You can check it out on this link. So about the hardware, you will need to have CX-GB400 and AXDM100 from XACTI, and you will need to buy the JST connector and contactor to make the power cable, and micro SD card to store your photos and videos, USB-A to USB-C cable, and some wires to make the power cable, and the Linux computer with the LORS installed. So you can follow along the installation step here. First, you will need to install the live UVC and the ROS2 Galactic and some dependency to build the package, and the V4L2 loopback. So this one you will need it for the video output, and install this package to the workspace. The camera and the gimbal can be controlled by ROS topic. There is a lot of command that we can use, but I just picked some of the useful command for simple and most usage for the robotics application. You can try check it out on what command we can use on this table below. For the setup, first you will need to source the ROS2 environment. And if you plan to use the Linux video device, you will need to set up the V4L2 loopback. And then after that, we are ready to go. So first you will need to launch the launch file from XACTI package, the camera launch.py. If you don't see any error, then it's good to go. And on the next terminal, first you will need to set up the camera orientation by publish XACTI camera orientation. In my case is the upper mount, so I will set it as 1. And next we need to enable the gimbal, because when first it power, the gimbal doesn't initialize yet. So we need to publish the XACTI gimbal restart. Then the camera will start initialization. So on this node, there is a ROS parameter called local play. If you set this parameter to true, you can see the video stream on the local stream. and you can turn it off by setting it to false. Also, if you want to see the stream from the image message, you can use the image tools with the show image and remapping to the XACTI camera view. So we can publish a photo capture topics to take a photo, and we can publish the video record to true to start recording, and publish the video record to false to stop recording. We can publish the XACTI gimbal pan and set the angle to 30 degree, so it will turn to the left side 30 degree, and we can turn it to the right side minus 45 degree, and we can get it back to center by setting it to 0, and we can publish the XACTI gimbal tilt to tilt the camera 30 degree, or 90 degree, and then tilt it down to minus 20 degree, and centering it back to set it to 0. If you have set up the V4L2 loop back, when you list up the depth video device, you will see the video 30, and if you use the command ffplay depth video 30, you can see the video output. And if you take the SD card and take a look inside, you will see the photos and videos that we took. The photo is in the 4K image with some information of the camera, and the video is in full HD resolution. And this is the ATCrawler, the vehicle that we're going to test with the camera. It used to DC brush motor with the rubber track. It's a heavy duty vehicle and it's good to run in outdoor in many robot applications. So this is our custom motor driver to drive this ATCrawler. So it has 2 channels to drive left and right motors. It has PWM input and S-bus interface, and USB connection for the ROS communication. I'm gonna place the camera in front here with the double-side tape just for temporarily. And we're going to observe on the video streaming to see how well the gimbal stabilizes. So for the test run, I'm going to use the depth video device 30 with my previous WebRTC application. So at first we need to set up the camera orientation and then enable the gimbal. And then I'm going to control the vehicle in manual by this radio controller. So far on the flat surface, the gimbal can stabilize the camera quite well. And next I will put some small stuff on the floor to let the crawler drive as the rough surface. We could see some shaking on the frame when the crawler is driving on the rough surface, and without the gimbal stabilization, I think the frame will be much worse. And the gimbal is doing the best for this, and so far this is good enough for many applications. and that is the demonstration videos about this gimbal camera and our ATCrawler. So my comments about this XACTI gimbal camera is it working pretty well, and there are many commands that we can control the camera parameters and control the gimbal, and everything is communicating via the single USB port, which is very convenient. I feel that the AXDM100, the mounting plate, is a little bit too big. So if we can reduce this a little bit to the same size of the gimbal base, that would be perfect. And this gimbal camera is good enough for many robotics applications. So if you would like to buy this XACTI camera, please check on their website. I'm not getting any promotion from the XACTI company. I just found that this gimbal camera is very useful. So I make the ROS drivers that you can interface this easily with your project. So if you like this kind of video, please press like and share button. And thank you for watching, and see you soon.